number one, complete this table. We got atomic number, mass, use a whole number, protons, neutrons, electrons, and the symbol of the element. So really quick, something I want to cover. I'm going to use this. This is a good indicator. So the atomic number, don't confuse that with atomic mass. The atomic mass down here of each one of these, as you can see, this is how heavy that specific element is. Now, later on, we're going to get into fancier stuff like isotopes and ions, but we're not going to do that right now. We're just looking at it as face value, as it is. So the atomic number is specific to each one of these elements. No other element can have number 9 except for fluorine. No other element can have 3 as the atomic number as lithium. Now, the atomic number is also the same as protons and electrons for now, okay? So this atomic number, if this is a 1, the protons will be 1, the electrons will be 1. The neutrons, however, is the atomic mass minus the atomic number, or you could think of it as the atomic mass minus the protons. It's the same thing. So get this periodic table out, and let's go for this guy. So the atomic number 9, like I said earlier, will still be the same amount of protons and electrons. That's wrong. Boom. Chill, right? The element in question, let's see, who has number 9? Fluorine. So up here, we're going to have an F. This is the symbol of the element. Neutrons. Oh, we need atomic mass. Can't figure that out. So we got 19. So 19 is the atomic mass. What is 19 minus 9? And now the reason I'm doing 19 minus 9 that way, I like to work left to right. So protons. So the mass minus the protons, which is 10. Yes. 19 minus 9 is 10. Easy, right? Let's do the next one. Okay, they didn't give us protons, 14. So the electrons are 14. The atomic number is 14. Which element down here has a 14? Boom, silicon. What's the weight? Or the mass? It's 28. Neutrons. What is 28 minus 14? Correct. It's 14. That one's not that hard. And of course, silicon is Si. Boom. Next one. We got the mass. Now this one's kind of confusing because, look, no other element that I know of outside of, let me erase this real quick. No other element that I know of that has a mass of 14. The only one I know is nitrogen, which would be 7. But here they have electrons, which is 25. And the only one that I know has electrons that are 25 is specifically manganese, which is, it just makes no sense. The atomic mass is 54. So I think we're going to go left to right. So I'm going to cross this out, and we're going to go with nitrogen. Just because, yeah, I don't know if that's a typo, but we're going to put an N. Talk to your teachers about that one. I don't know where they got that from. 7. Protons is also 7. Atomic number is also 7 because we're doing nitrogen. Okay, not hydrogen, nitrogen. So 14 minus 7, yes. So that would be nitrogen. Now, let's go down a little bit more. See, now we have manganese, which is 25. Let me erase that since we're on manganese now. Right, 25 is the atomic number. So if that's the atomic number, the protons is 25. See, matched up, and the electrons would also be 25, and obviously manganese is Mn. Now the mass, 54, we're doing a whole number. I'm going to round it up. So that's going to be 55. 55 minus 25. That gives us, what, 30? Yeah, 30. So that's pretty much how we do it. So remember, atomic number is the same thing as the protons, which is the same thing as the electrons. Neutrons is the mass minus the protons, which give us the neutrons. Pretty simple, right? And obviously, you know, the rest is just signed out like that.